All right, now this is a complex fraction, and I don't know about you, but it looks pretty scary to me. When I have a big fraction with two little fractions inside, I almost want to run away. But what we want to remember about complex fractions, it's just another way to write division. And as long as we remember that this line is a division line, then this shouldn't be quite as scary. So remember, to solve division of fractions, we use that keep, change, flip. So you've got two choices here. You can go straight from here and do your keep, change, flip, or you could rewrite this. So I'm going to do the first one. I'm going to do the keep, change, flip first. So we'll keep the first, change that to multiplication, and flip that. So we'll have 18 over 4x times, flip it. Then we want to do some cross canceling. 9 and 18 can both be divided by 9. 4x and 8x, that's 1 and that's 2. And then we've got 2 times 2 at the top and 1 times 1. So our answer is 4. All that scary stuff to come up with the number 4. One thing I want to mention here, when you are doing the cross canceling, you have to be careful. There's a common mistake that's made. Like here when I said 9 and 18 could both be divided by 9. Because I just said that 9, sometimes I may write a 9 here instead of a 1. Even though I just said 9, they can both be divided by 9. And so you just want to be careful that you're not saying the word, the number that you just said, that you're putting the right one. So 9 divided by 9 is 1. 18 divided by 9 is 2. We wouldn't want to accidentally put the 9 there. Alright, so the other way to do this is we could go ahead and just write this out. So I'm going to take this same problem and I'm going to rewrite it as division. So if I'd have 18 over x divided by 9 over 8x, which when I do the keep, change, flip, well, let's include the 4, Cindy. Then you'll see that I'm ending up, this is the same thing that I have there. So either go straight from here to here or rewrite it as division and then do the keep, change, flip. Resume. Here we have an interesting complex fraction. We can go ahead and add these. These are going to be easy to add. 3 plus 1/2. We're talking 3 and 1/2. 4 and 1/2. If we change these to fractions, to improper fractions, I'd have 6 7/2. 4 times 2 is 8 plus 1, 9/2. Now I have that complex fraction. I'm going to do the keep, change, flip. So I'd have 7/2 times 2 over 9. The 2's cancel, and we are just left with the 7 over the 9. This problem's a little bit more difficult. I've got to get a common denominator. So I want to remember that I'm going to write these whole numbers as fractions. And then I need a common denominator. So here on the top one, I can use x. So I'm going to multiply, the bottom and the top by x. At the bottom, I can use 9x. So I have to change this one, 9x, 9x. So I'm going to end up with 3x over x minus 5 over x. 9x squared plus over 9x plus 8 over 9x. I need it to be one fraction on top of one fraction. So I'm going to go ahead and simplify this and say 3x minus 5 over x. That takes care of this numerator. Then the denominator is 9x squared plus 8 all over one denominator. Now I can do the keep, change, flip. So we will have 3x minus 5 over x times, flip it, cross out whatever you can, and we've got 9 over 3x minus 5 over 9x squared plus 8. Then we have to know, is this reduced? I can't factor this. They have nothing in common. There's nothing else I can take out of here. So this is reduced. And we're going to leave the answer factored. So we're taking and we're putting together a lot of things we've reviewed over fractions. We have to get a common denominator. We wrote the whole number over 1, decided x was the common denominator, so we had to multiply the top and the bottom by x's, and see, x over x equals 1. So we don't change the value of this number, we just change the appearance. Same thing here, stuck the x over 1, decided 9x could be our common denominator, multiply top and bottom by 9x. We use that product rule for exponents. 1 plus 1 gives me the 2. And then we put them together as much as we can. We add and get this 1 over 1 denominator. Now we're ready to do the keep, change, flip. All right, so let's look at another problem. This one's going to be a little bit complicated also. All right, so get that written down. Sometimes I have a hard time seeing which is the big fraction line. So this is the big fraction line. We want to go ahead and factor this because we're going to need a situation where we can get it into just one fraction over another, and we're probably going to want to do some canceling hopefully later. So we're going to go ahead and factor this as we go. So we'll have x minus 3. This is the difference of two squares. We have this 1, and we need to write it as a fraction with the same denominator as this. So x minus 4 over x minus 4. Same denominator, and when they're the same top and bottom, it equals the 1. We want to get this together. This has a lot of numbers in it, but it's still just one fraction. Here we've got 2 we need to add together. So a negative 4 plus 1 would give me a 3. So at the top, and then negative 4 plus 1 is how I get this 3. Okay, so we've simplified that. Now it's time to do the keep, change, flip. When we're ready to multiply, we can cross cancel. We've got x minus 4 at the top here and at the bottom here, so they cancel. X minus 3 at the top and at the bottom. We use the word cancel, but when these are on top and bottom, it's like here, it's equal to 1. You know, when these are on top of each other, we're talking 1. So it doesn't really, the numerator doesn't disappear, it just becomes 1. Then we can multiply. To come up with our answer. I want you to do some practice on this one too. And I'm going to do one of the more complicated ones for practice. Okay, so again, go ahead and pause your video and work. And then when you're done, come back and see what the answer is. To get started on this one, I went ahead and wrote the whole numbers over 1. We're going to use x as the denominator, so I'm going to multiply both of these by x to create equal fractions. Did the same thing in the denominator. Put the x over the 1, since it was a whole number here. Use 4x as the denominator. Multiply it times the denominator and the numerator. Then we're going to take and put those together. We're going to go ahead and do the subtracting and the adding so that we'll have one fraction. Then we can do our keep, change, flip. Cross out anything that's alike. And multiply. because we've already looked to see if we could do some cross canceling and reducing, we couldn't here. So we're not going to be able to do it here. One thing I want to point out and remind you of is you cancel when you are multiplying. So because I'm multiplying here, I can cross cancel here. But this minus 3 is part of this 2x minus 3. So I can't take and cancel that 3 and this 3. This 3 is part of something bigger. This 3 is part of something bigger. It's not by itself. The x's, you know, we can cancel those. Okay, good luck. And that is the end of chapter 7.